All right. Well, good afternoon, everyone. We're going to get started. Hi. All right. Hopefully everyone's had a nice lunch. I just flew in from Dallas this morning. Arms are tired. That's the joke, right? I'll start by saying who I'm not. I'm not Dr. Jeff Wessler. So if folks have met him before, we're expecting a Dr. Jeff Wessler to come up and speak today. I apologize. I'm an audible. In fact, I'm an audible of an audible, but that's neither here nor there. My name is Mark Roboff, and I'm assuming all of you fine ladies and gentlemen are here for the Watson session, or our session on cognitive computing. So before I talk a little bit about myself and take us through exactly what we mean by cognitive solutions, I just want to get a quick couple of shout-outs from the audience. What do you guys hope to learn today in the next 45 minutes? If anything.
How soon will it be before the computers take over?
Indeed. Well, I can't give you that answer, but we can, hopefully qualm any fears. Anyone else? Oh, that's very good. So, so as I mentioned, my name is Mark Roboff, and I've been with IBM for 6 years. Out of 5 of those 6 years, I've worked the core of our Watson set of technology. And I've been a part of Watson Group ever since we decided to take that set of Watson technology and make a group around it. So I have been in the thick of it, so to speak. I'm a lifelong New Yorker. I have a long history of working with both state and federal governments. I've worked with Illinois and Texas in the last couple of years, the province of Ontario. Our federal government, governments in the Netherlands, Belgium, and the UK. This is admittedly my first time to Sacramento, but I'll tell you something. I'm very excited to be here, because after 5 years of starting and stopping the plan, my wife and I are going to move to California at the end of March. And I have to tell you, as a lifelong New Yorker, I already like Sacramento a hell of a lot better than Albany. I don't know if anyone's ever been to Albany, but I can't recommend a single thing about it. Ouch. Ouch indeed. So what I'm going to do over the next half an hour is introduce all of us to what we mean by cognitive, right? We, as the IBM company, are making a big bet and an enormous investment that cognitive solutions are the wave of the future, that they're going to transform government, commercial enterprise, and just about every which way we interact with computers for whatever we do, right? So what do we mean by that? And what does a cognitive solution look like? Hope to answer that question in the next few minutes. Then we're going to take a look at 3 specific use cases in the public sector where we've had tremendous success with cognitive. We'll talk about a federal use case around watchdog activism and regulation. We'll talk about a way state governments can serve more people in a case-based nature while lowering operational expenses. And lastly, we'll talk about public safety at the state and municipal level. And I know that could be a little bit of a touchy thing given recent events in the south of the state, but I hope this is something that will be very useful to listen and hear about. And then at the end, we'll make sure we have time for Q&A. So, up until now, computers have always been about data, right? Data to operate our departments, our missions, right? The activities and the transactions that make up what we do. And of course, data to analyze how well we're doing what we're doing. Are we doing the right thing, right? But what is expertise? What is the difference between expertise and simply data or information, right? Well, it's hard to say a computer is an expert in anything. Computer is just a repository for data. A computer can have programs that can operate programmatically on that data. But at the end of the day, computers know nothing. Computers are stupid, right? Certainly not experts. So what's the key difference? Well, if I'm an expert in something, or if you're an expert in something, right, you have information locked in your head the way a computer has information locked in a hard drive. But you have a certain understanding about that information. You have a certain context in which you use, read, interpret, keyword, right, and ultimately act upon that information. That makes you an expert. A cognitive system, a cognitive solution, breaks new ground in allowing computers to be experts too, allowing computers to understand information the way we as human beings understand information. We have methods for computers now to learn expertise, to learn a domain, to become an expert in that domain. We can codify expertise into computers, just like we've been able to shove data into computers and algorithms and operations on that data for, well, almost 100 years now. And what does that mean if we now have a system that simply doesn't store data, but understands what it stores, understands a business domain or department domain or a mission domain, right? Can act as we act in interpreting that information, can interpret it with the right context, in the right way, in the manner that our best experts would do on a daily basis. Well, what it means is that we can now take the best of human operation and the best of what computers can give us, scalability, and we can now mix, right? And there's magic out of that. So let's drill this down a little bit more before we look at the effects of this. Right? A cognitive solution democratizes innovation by scaling expertise. There is a lot of data out there in the world today. Right? I'm not going to start talking about big data. I imagine some of you have heard stories and presentations about big data many times till we're all blue in the face. Right? We know it's out there. We know it's coming from more places. We know it's not just the information that you'd put into a database or a case system. Right? We have machine data. We have social media. That's data too. Right? We have all sorts of unstructured information in our departments, in our offices, that we don't make use of because computers, until now, haven't been good at making use of unstructured information. Computers haven't been good at understanding language until now. Right? Now, we can collect all of that information. We can understand the parts that have been difficult in the past to understand through what we call natural language processing. That is a core tenet of cognitive computing. Being able to read, comprehend, understand the meaning behind text. And we can integrate that information, just like we would integrate data in a database to power some sort of transactional system, like when I sign up for an appointment at the DMV. Right? But we do something now. We do something new after we've done all of that. Right? That's where the world has brought us to 2015. What we do in a cognitive system is via machine learning, we train a computer, right, to take all that information that it's now been given and understand it in a particular way, in a particular domain for a particular mission. Right? And we teach that computer how to act on that information when it's, say, asked a question or when it's presented with a problem or a dilemma. And that is codifying expertise into a system. We train it, not program it. That's another big shift, right? The first big shift, computers can now understand text. They can understand human language. That's the first shift of cognitive. Second big shift, we don't have to program rules and logic into computers anymore. We can train, right? As if we're a teacher, training a student by providing example. Right? Once we've built this expertise into a computer, we now have the scalability of computers to act with the smarts of a well-trained human being. Right? And it's not simply putting rows and rows and rows of data banks together, right? Arthur C. Clarke style. Let's think about this for a moment. Right? The way computers act on information, the way humans act on information, even computers that understand expertise, right? There's certain differences there. We take advantage of those differences. Fun one to talk about is cognitive biases. So how many times, right? Well, I don't know if we're any of us are researchers, so maybe I won't start with saying how many times, but right? Hopefully all of us have heard of a cognitive bias before. Right? If I'm a debater, right? I went to Carnegie Mellon, but actually graduated with a public policy degree. So we did a lot of debating. If I'm a debater, and I believe personally in my heart on the pro side of a topic, but I'm asked to debate a con, right? After I do that debating, I might actually start taking the con side. Right? That's an example of cognitive bias. Get my emotions in the mix. Right? That's a particularly interesting one when we talk about what's coming down the pipeline from IBM research. Right? We're building a big debating system. Right? Computers, right, they might understand expertise. They might now know how to converse with human beings, right? The way human beings like to be conversed, well, not conversed with, but the way human beings like to converse with other human beings, indeed. Right? But computers still don't have emotion. Right? Computers can look for things in long tails that a human being just can't capture. Right? A computer can read billions of pages of text in an instant. A human can read billions of pages of text in a billion days. Right? There are advantages to having a computer think and act at a human level, right? Understanding expertise. So what do these things look like in real life? Right? A cognitive system has two parts. The first part is all around collecting and organizing that information. Now, this is a little bit of an IT thing, right? We all have big IT departments that spend a lot of money and a lot of time taking data from one area, taking data from another area, merging them together, putting it in a warehouse, trying to get something useful out of that. Right? Cognitive systems can do that very easily, very quickly, and much less expensively than traditional IT, analytic, data warehousing, ETL, folks might think that they'd be able to do it in. Right? Cognitive systems work not just with traditional data, but unstructured data. Cognitive systems don't just work with information in the enterprise, but also social media, information from external sources, right? Information that might come from the Internet of Things. I know, for instance, that we live in. I like to sprinkle in little personal stories, right? So, I live in the Northeast for now, right? Moving to California at the end of March, right? And in the Northeast, we have toll roads. We don't have freeways, right? We have expressways, and we have turnpikes. And I've never gotten a rental car here in California with FastPass, but if you ever go and get a rental car in the Northeast, you'll have Easy Pass. It's what all of the states use from Illinois to Maine down to, I think, Maryland or something. And it's that electronic toll transponder. And I had a friend who wired his toll transponder to quack, but a little duck, like one of those rubber ducks, you squeeze it and it quacks. But he wired that duck into the transponder, right? To quack every time, right, something pinged his Easy Pass. And he was really surprised when it would quack every 2 minutes on, the New Jersey Turnpike, right? Certainly, there aren't toll roads or toll booths every 2 minutes on the New Jersey Turnpike. That road actually you only get tolled entering and exiting, right? But there was a big brouhaha about this, right? What are they doing? Are they going to give me a speeding ticket if they know I got on at Elizabeth and got off at the Pennsylvania Turnpike exit too soon? Well, they don't, at least not yet, do that in this country. I hear they do that in Australia, but not here. No, it's just recording easy passes to get an understanding of traffic patterns, right? And they've been doing this in the Northeast for years, decades perhaps, probably decades, right? Easy Pass came into the scene in 1993, right? Is California doing this with Fast Pass? I think that's what it's called. Yeah, Fast Track, thank you. I travel the country every week, I get confused. Probably not, because I actually have not met too many people with a fast track, right? Except for the folks on the 110 Express going up to LA. That road is never, ever, ever crowded because there's no one on it, right? But this is just a great example of being able to take Internet of Things, right? That just, recording of information, getting it into a cognitive system, looking at that information, applying expertise around traffic management, and voila, right? You now have a single system that can see everything and act and respond and modify streetlights and turn on, those freeway timers, right? Where you have to drive up and wait for the green light, right? Automatically. That's pretty neat, right? So it begins with data. The second piece of it is applying what we call Watson capability, right? It's those three things: understanding human language, machine learning, and then something more, right? Watson has a capability, once it's understood, right? When we call Watson, that's our code name, our brand name for cognitive systems, cognitive solutions. So in addition to being able to understand human language and in addition to being able to learn via example, right? These systems can make judgments, right? They can determine, if I ask it a question, what out of many different answers is the most likely correct answer, given the context, given who's asking, given the area of expertise I've been trained on, right? And it's this last thing that brings us from systems of analytics, right? Now, it's great to have Internet of Things data brought into one place. It's great to be able to slice and dice that information faster than we've ever thought about doing it before. But there's still, without anything else, there's a bridge, right? We have a computer saying, do this, and then the human has to say, I wonder if I should do this. And then if the human agrees, the human has to go do it, right? But imagine a system that we fully trust, a system that we fully trained, seeing what to do, and then being able to reason and deduce and make the judgments, just do it itself, right? When we talk about scaling expertise, the scaling comes very much in the third part. A system that not just can analyze, can do the research, but can now act on its own analytics. Now, going a little bit deeper into this before we talk now about use cases, right? What makes up, if we were to come to say, hey, IBM, we want to look at a cognitive system for case management in family and child services, or we want a cognitive system to look at traffic patterns, right? Because more and more people are getting fast tracks, right? Well, what would we actually deploy? What would we implement? Right? There are two pieces. The first piece, right, is that hub for aggregating all this information. This can be on-premise, or it can be in the cloud, right? Some who may have looked at Watson before have probably heard it's all cloud-based, right? And I speak to a lot of folks in the public sector who say, well, what can I do with that, right? Watson's not, and when I say Watson again, IBM's set of cognitive solutions, not just cloud-based, right? There are very, very mature, very, very robust on-premise data aggregation and integration hubs that form the foundation of any cognitive solution. On top of that, we have our cognitive bits of magic grouped into those three thematic technologies, right? Understanding human language, machine learning, and reasoning. These technologies, right, are sliced into what we call APIs. An API is simply an interface. It's a computer interface, not a human interface, for a bit of technology to work with other technology, right? Think of it as a Lego block. And think of the API piece as the little round things that stick up and stick underneath that allow you to connect that Lego block to other Lego blocks to build a house, right? Or a Star Destroyer. All right, so we have all these different little Lego blocks, and you can pick and choose and use the Lego blocks, the APIs, the little bits of cognitive capability to build your Watson solution. They're organized around really 4 groupings. Right? We have Lego blocks that help you understand data and can provide insight into that data. Things like sentiment and content analytics. We have little Lego blocks that can understand speech, right? And turn that speech into text, right? And provide all sorts of tonal analysis, right? And even personality analysis on that text, right? To help either a human agent or a cognitive agent interact with a customer. This is very new and still in development, but we're even building ways for our cognitive solutions to see, right? To see those traffic cameras and deduce how fast cars are going, how many cars are on the road, right? And again, we have that cognitive solution sitting in the background saying, well, I should lengthen the red light on that freeway metering thing, right? Which again, you don't see much on the East Coast except on the Long Island Expressway, which is a joy of a road to drive, right? And lastly, language. We have capability on premise, right, in that foundational information component to slice and dice and understand language. But a lot of understanding language and a lot of understanding expertise comes from building blocks that supply machine learning. And I'm not going to spend too much time on this slide deck, right? But this is just a menu of the current building blocks we have. I'll talk about one. So we have something, this is actually made a year ago, actually 2 years ago now, called Personality Insights. It's a great sampler to the magic of cognitive computing. What it can do is it can take text from a known author, right? And a fun demo is to supply it tweets. It doesn't have to work off a lot of text. And here, our Personality Insight system, a cognitive system in and of itself, has been trained on personality profiles, like Myers-Briggs. But we didn't use Myers-Briggs. We used Big Five and a couple other ones. And what you can do with this little API, this little building block, is you can feed it text, and outside, and it's going to give back to you a reasoned analysis of that author's personality. Right? So it's just a fun thing, and I know folks will have access to the slides. That's a live link. You can click on that link, and you can navigate over to the Personality Insights icon and play with a demo. A little crazy. Right. And of course, we're building more demos, but we're building, much more importantly, more capability every day. Right. Our cognitive journey at IBM started with what I like to call a publicity stunt, but man, it was hell of a stunt. How many people saw Jeopardy? All right. A computer that could answer questions, right, in a game show under 3 seconds with all the funky rules that Jeopardy lays on the contestants. That's pretty neat, right? And that took a lot of natural language processing, understanding speech, and machine learning, because it would be impossible to write rules to comprehend, right, the internet's worth of information, or well, really Wikipedia's worth of information. Imagine how long that would take. But since then, we've expanded Watson into lots of different interesting spaces. Government of Singapore is using Watson today to answer tax questions. If I'm a resident in Singapore and I have a question about filing my taxes, I can go to a Watson agent, ask my question, and it will give me an answer. Tomorrow, we'll have systems that can even take your tax return for you, process it, and deposit a refund in your bank account. We have, and hopefully folks know about this too. We've gotten a lot of publicity about this. Systems that have been trained on cancer diagnosis, right? We've built two. We built one with the MD Anderson Cancer Center, right? They use it internally. We built another with Memorial Sloan Kettering in New York. And we've actually partnered with Memorial Sloan Kettering to build a little oncology department in a box, if you will, to sell to major regional hospitals that would like Memorial Sloan Kettering's expertise, but don't have the resources to turn themselves into a third major national first-tier cancer research center. Right? So this is a system where you can input a medical record, right, a patient's diagnosis, and the output after this cognitive system looks at the record and consults the database of Memorial Sloan Kettering's knowledge on oncology. It'll output a treatment plan. It's very neat. We started with one language for Watson. We now can presumably speak 5. There are pieces of Watson that actually can speak several dozen different languages. But in terms of the deeper learning components, right, we now have Japanese. We now have Brazilian Portuguese. We have Spanish, English, of course, and I think we're building French. Right? So we're climbing that ladder very quickly. Right? We started just 2 years ago. So working with cognitive, right? We're going to talk a little bit about use cases. Right? Every cognitive journey, we could say, has 4 steps. And what's important here is we aim for the customer, whether that's a public customer or a private customer, a commercial customer, to get value out of each and every step. Step 1, for whatever mission, is to identify the information that we're going to build some expertise around. Right? What do we want this cognitive system to do? If we want this cognitive system to answer questions about car registrations, we have to find the set of information, right, to teach it about car registration laws in the state of California. Once we've done that, right, we can get that information into one place. Right? We do that aggregation and that information integration. And from that, we get accelerate. Right? We can now have systems of insight, right, in one place versus in siloed data systems that are hard to access that help make, you know, our regular office workers, our regular case workers, our call center workers, all that more productive. Right? Then we're able to enhance those data systems, those insight systems, with more information coming from other areas. Pull in social media. What are our constituents most interested in? What problems are our constituents having? Right? This is where we build that expertise into the system. We train it. How to act like a call center agent. How to act like a caseworker. Right? And once we've trained that system, and depending on this is, I'll save someone from asking the question because it's always asked, how long does it take to train, right, a cognitive system? The answer is it depends. It depends on 2 things. It depends on the breadth and complexity of what you want to train it to do, and it's really the breadth and the complexity of the information domain, right? And then, second thing is, well, what are you going to have this cognitive system do? Are you going to have it answer simple questions that, you know, are simply stated on a FAQ somewhere? Or are you going to have it recommend cancer treatments? So a very simple application, you know, that can do question answer on a very limited domain, like, I don't know, car registrations, hoping that's limited, right? That might take a couple of months, right? 3 to 6. Cancer, 2 years, and maybe then some. But the good news is that the training piece is getting better. This is where IBM is focusing now a lot of its effort to continue to make our Watson set of technologies consumable by government and enterprises, large and small, for projects large and small. And we started with a research asset that could play Jeopardy. Then we spent a few years building systems that can look at cancer. Now we have lots of different Watson systems We have all sorts of different tooling that's coming out that makes this training process easier. It's going to get easier and easier and easier to make use of this as the days march forward. And once we've trained a Watson system, then we can take advantage of that scalability, right? We can have that system be a call center agent. We can have that system be a caseworker. We can have that system monitor all of the traffic cameras in the entire state. Options are limitless. Let's talk about 3 real examples of Watson in the public sector. The first is my favorite, because it's actually my legacy in Watson Group. This is a solution that over the last 5 years I helped build and grow and market. And we call it product safety and quality. How many people in this room drive a General Motors vehicle? All right. I'm gonna single you out. Well, maybe not. Maybe I'll be a little kinder. How many people drive a Toyota Prius? Anyone drive a Toyota Prius? Okay, you have some company, right? How many people remember 5 years ago, the big brouhaha, the big scandal on Toyota Prius and braking, right? How many people remember just last year, the scandal around General Motors and ignition switches, right? All of this information had been a matter of public record, right? As people started having problems with their cars, they'd complain to Toyota, they'd complain to GM. Very clearly, Toyota didn't do anything, right? Very clearly, GM didn't do anything, right? $900 million fined to GM, says it didn't do anything for a very long time. And when you complain to the automaker and they don't do anything, who do you complain to next? The government, right? The call center of last resort. Right? NHTSA, the National Highway Transportation Safety Administration, right, is, for vehicle issues and crashes and complaints, their call center of last resort. And they've been collecting all this information for years. And a couple of years ago, they started using Watson to sift through it, to very quickly see what was going on, and to also very quickly identify root cause, right? Identify, to get all the information together, accelerate, right, to very quickly see what was going on. They didn't have to spend months researching. It was right there in front of them. And enhance, not only can I see what's going on through just simple data counts, right, but going into that unstructured information, using Watson's ability to extract meaning, understanding from that, I could very quickly get to root cause. Going back to the Toyota story, this is a little bit pre-Watson, but still, this is the same technology, the same capability that drives this solution. We showed Toyota that the problem with the Prius was huge, that was easily identifiable. And at the time, Toyota said the problems with the formats. And it turns out formats were a little bit of a red herring, right? There are some issues where the formats that weren't secured to the floor of the car, but the real problem was with the anti-lock brake system. And Watson's ability to understand unstructured information, to pull out root cause. We were in Toyota's offices, and in 5 minutes, right, figured that out. 5 minutes. Let's fast forward a few years. There was an article in May of 2014 in the New York Times by a NHTSA director of public safety that said, we've been using IBM's unstructured data analytics system, and now Watson system, right, to really understand the scope of this GM ignition key problem. Okay. Within a couple weeks later, talking to GM, we found a lot of cars that needed to be recalled. Mary Barra, November of that year, said at the Davos Economic Forum, and for those that don't know, Mary Barra is the CEO of GM, we have our vehicle safety situation under control, thanks to Watson. Now, I talk about automotive examples here, but really this is a use case for any government watchdog or regulator to look at what they are watching or regulating, to be proactive right? When an issue comes up, right, we can get in front of it with a solution like this versus having to wait for it to balloon and either cause deaths, billions of dollars, or both. And if we think about the scalability of this, this doesn't use all three components of a cognitive solution. There's no machine learning in this yet. But apply machine learning, right? Apply an expertise. Train the system how to do its own research instead of just aggregating information and using natural language processing, that understanding of human language to bubble up root cause for a human to decipher. And now you have something that can go from the investigatory to the predictive, right?
So let's widen that one back a little bit to GM and so forth and analytics. So you can imagine what you're trying to do in the end is get it anticipatory. So you're seeing this before a huge amount of complaints come in. And so what happens is that the automobile company, what the key thing for them is to when the cars come into the dealerships and they get repaired, they want to be able to see all that very, very early on through the back end of the dealer's system so that they can start identifying patterns of defects and so forth and go back to the assembly line and also know, earlier before they do a big recall. And one of the problems is just getting people to put it all in, but they end up with these logs every day and then they go and do an investigation. So I'm curious how Watson would work in that respect. So it's basically, so you're trying to nip it before there's a lot of the complaints and then miss it. The other thing is then when you look at the Tesla model, which basically it's all over the internet, online over the evening, you can imagine a system with the sensors and Internet of Things where the car is actually telling you directly, talking directly to essentially Watson and letting them know over time, almost the human being not even having that big role in it. So
Before I answer that question, can I get a quick time check, or I can look on my computer?
Or if we run out of time, we can do that.
Yeah, so I'm going to answer that briefly now, and then afterwards, if you have remaining questions, we could take it offline. But being able to take other data sources, right? It's a key component of a cognitive solution. Being able to merge those data sources into a single view, right? A single understanding of concepts, entities, relationships. It's a key foundational component, right? So you can imagine an automotive manufacturer starting with government data. It's easy to get. It's free, right? You don't have to do anything to integrate it into your own systems to get value out of that. But as you start using it, adding in your own maintenance logs, adding in your own warranty reports is very easy. Machine data from Tesla takes this further. Right? Now that's not going to be nearly as descriptive as a warranty report or maintenance log because it's numbers, mostly. Right? But one of the especially for those of us in IT and those of us in IT who have sat through lots of different IBM presentations over the last 5 years, one thing that is remarkable about IBM's approach to cognitive is that we're no longer distinguishing between structured and unstructured. It's all content. It's all information. And our solutions here don't care about that distinction either. Right? They can take information that's tabular, that's numeric, that's quantifiable from a database, from a car in real time, that's historical, whatever. It can merge and integrate that information conceptually with unstructured narratives without nearly the IT infrastructure investment that you would typically do to have two databases merged together. So, right, we talk a lot in Watson about machine learning, and we talk about its ability to reason and deduce because that's the fun, sexy stuff. But let's not underestimate the power in information aggregation and information integration that Watson's technology, right, and our cognitive solutions bring to the table. Let's move on to digital virtual agent. Now, this got its start, I will admit, not in the public sector space, but in the insurance space. But it easily translates, right? Government of California, just like any state, has different departments that interact with the public, right? That offer either call center services, caseworker services. What a digital virtual agent is our classic question-answer use case, or classic question-answer capability, which a lot of people like. I mean, that was Jeopardy, right? Answer a question. Don't give me a Google search of results and help me go mine that information for myself. Just answer the question. And people like that. But, and I'm talking about my own personal observation here, working with customers all over the globe. If I step back for a moment, how valuable is a system that could take a year to train, if it's a complex domain, and can cost quite a bit of money, 7 figures, to just answer questions, right? Google's getting better. I might have an FAQ. Is it really worth that big expense in time and cost to just have a system answer questions? Maybe not. But what if I had a system that not just was able to answer questions, but then transact with me? What if I had a system that was able to, let's say I am filing for a permit, right? I'm building a house. A system that not just answered questions about that permit, but it actually helped me create the application, could submit the application, and can deliver to me a permit. That's what the digital virtual agent is all about. It's taking that QA use case and bringing it to the next level. Not just a system that knows, but a system that does. Now, here, we're in the early stages of identifying, right, public sector use cases for this. But this is where we can really see the benefits of scalability, right? At the end of the day, you could serve more customers instantaneously. It's not just serving more customers in less time. You could serve more customers instantaneously without having to expand staff. Right? I know a little bit about California. I know about Proposition 13. I know how hard it is for government agencies in this state to get budget. This could help, hopefully. Lastly, public safety and security. So this is used now in various levels in federal governments, but got its start in Florida. I think it's Florida. I'm pretty sure it's Florida. I know it's Florida. The municipal police force. This is a system that at its core brings in social media information, can slice and dice that social media information. Today it brings in much more than social, to catch the bad guy before the bad guy does the bad thing. Right? I'm going to go there just because, you know, it's easy and relevant. Right? After San Bernardino, people came out about all these signals. Right? If you're able to get the information, you can have this system get those signals. You can have that system say, well, right, we're seeing threats posted on Facebook. Right? We have in the IBM R&D drawer and in our more advanced offering, systems that can do identity matching, can link a Twitter account as best as possible with personally identifiable information, who could then say, well, you know, we had this person stopped at immigration at LAX, right? And can put those links together. Is it foolproof? No. Is it the perfect be-all and end-all? Of course not. But could it give a law enforcement agency extra time to think and act before it's too late? That's been proven. So this integrates not just what we call our cognitive capabilities, but a lot of other IBM software in the law enforcement space, such as I2, right, which is used by police forces all over the world to do a lot of link analysis, to do a lot of signal analysis, and to show quite clearly what's going on, right, to help agencies, detectives, right, information specialists find patterns. And it's not going to be, right, Minority Report. It's not going to be Skynet. It's going to give your law enforcement agencies, right, and the law enforcement agencies in the different cities and municipalities in the state more time to think and act, right? And just having an extra hour or 2 hour, getting a tip, right? It's a system that gives you tips, just like a good citizen who is at the right place at the right time, could save lives, right, and has. So just a couple of key examples. When we look at the public safety and security, here again, we apply the same value chain. We identify the information we want. Social is very, very big. I'd say it's that primary data source for a solution like this. Pulling that information together and using Watson's understanding of human language to extract key place names, right, key operative terms, from the noise in Twitter and the noise in Facebook, that's accelerating. Being able to merge that information with other data sources, right, that might be internal or external, that we can get from peer agencies, that's enhancing. Right? And having this system then do the research on its own, turning it from just a very advanced dashboard, and we know law enforcement agencies have plenty of dashboards, but turning it from that dashboard into something that can call the tip line itself, that's that scalability. So I know we're running out of time. Those are our 3 public use case solutions I wanted to share with you this afternoon. And I'll stop here for Q&A with 5 minutes to go. Yes?
So you talked about Watson being able to reason and deduce. When humans do that, based on our personal characteristics or training, we kind of come at it with a different lens.
Yes.
So, an IT guy would have one lens, accountant, myself as a social worker, I come at it with a different lens. How does Watson deal with that?
It's an excellent question. So Watson, right, can have a single repository of information. And before I even back up, because I've been trying to not use the word Watson, right? So the moment we use the word Watson, people think of a box in a room that will one day turn into Skynet, and that's silly. First and foremost, Watson isn't a box. It's not even a thing. It's not even a single program on a computer. It's a set of technologies. It's those 3 sets of thematic technologies, right? So Watson doesn't have this all-encompassing internet's worth of information. A cognitive solution utilizing Watson technology might have a single set of information. But then upon that set of information, you might build different perspectives, right? We talk about adding expertise to information. Right? You can add multiple sets of expertise on the same set of information. The expertise of a social worker, the expertise of an IT executive, right? And you could build different use cases, endpoints, applications out of that different set of expertise, whatever you would need the system to do. Yes?
Well, you also said that it eliminated bias, but you just said right there you've effectively selected which biases upon which to build.
So when we talk about bias, right, we're not suggesting that it's going to eliminate the bias of a social worker looking against that same set of information that a detective might look at, right? Because those type of biases are very much part of sort of the expertise that those social workers or detectives bring to the table to do their jobs. We're talking about, when we talk about eliminating bias, those little cognitive traps that you might have heard about in either a self-help course or in a psychology course in college. Things like being able to, look at patterns. A human brain, right, might be reading. A human being with a human brain might spend a day reading, right? Can you we might read very carefully what's on page 100, but by the time we get to page 300, we might not have as clear a memory of what happened on page 1 as what happened on page 300, right? And if we're trying to make conclusions on something based on what we're reading, right? The conclusions might be weighed because we're humans and we have our faults, right? Based on what we're reading on page 300, when maybe one, the thing we read on page 1 is just as important. That's the type of bias a computer isn't succumbing to.
Any other questions? Yes.
So does this have a public policy kind of application?
Oh boy. So we have seen the need, not the need, but yes, the need, but also the value of a public policy Watson for a very long time. When we started with bridging out Watson into different commercial applications, looking at a policy system had been a very early get-go for us. A system dedicated to policy is one of those complex things like a system dedicated to cancer. And we don't have one for market yet. We talk about IBM grand challenges from Jeopardy to the chess system before that. We're working on systems around debate, right? Being able to think about a topic from many different angles, being able to weigh pros and cons, being able to talk about compromises. And those are the tenets of a system, I would think, that can talk about policy. Right? So we're focused on it. It's an area of active research. Well, thank you very much. I'll stick around for a few minutes. I think though it's 3 o'clock, so. But it was lovely to be here today. Thank you.